What is shuffling, right? So shuffling is a process that occurs when the data is redistributed across different partition, that is nodes or workers in a cluster to perform certain transformations like a group by, reduce by, join, etc. Right? So this is the basic definition of a shuffling. So so basically what it means is that you have data in different nodes, right? In the cluster. So let's say you have a data in node 1, node 2, and node 3. Sometimes we need to transfer data from node 1 to node 2 or node 2 to node 3. So this movement of data is what is called as a shuffling. So why is it necessary? So let's understand with a simple example, right? So what I have right now is a simple use case where we have an input data. So I can consider this as an input data, right? So my input, as you can see, I have certain words like mango, apples, grapes, right? Now, in a cluster, what happens is some of this data would reside in one node, some in another node. So if I consider this as my cluster, so this is my node 1, this is my node 2, this is my node 3, right? So let me represent this. So this is basically my node 1. So assuming that I have three nodes, this is my node 2 and this is my node 3. So basically this is my cluster. So this is my Spark cluster, right? This is my Hadoop cluster. Now, then what happens is that you have to bring, so this use case is basically to count the number of words, right? So how many number of apples are there, how many number of grapes are there, how many numbers of mangoes are there. So this is basically what happens in the map reduce architecture. So you have the data in different nodes. Now what happens is, right, here within each node, so what we do is we basically give it a number, like we convert this into key value pair. So key would be your mango number, and then value would be 1, right? Because this basically says mango there is count 1, right? So this is basically our map phase. So in map phase we just assign a value, key value. So here the same data is just represented as key value. Now look at this, right? So if I want to count number of mangoes, all I have to do is I have to see how many mangoes and just have to basically count how many values are there, right? For example, mango is 1, right? Here 1, there's another mango 1. So I should say 1 plus 1. So that is 2 mangoes here, and then 2 plus 1, 3 mangoes here. But the problem here is that my mangoes are in different nodes. So I have data mango here, I have another mango here, I have another mango here. So I cannot count it when we have data in different nodes. So we need to bring all mangoes together. Like here you can see we have all mangoes together, we have all apples together, we have all grapes together. So what we did is we basically brought mango from here, and this one here to this data node. Similarly, we did for the other fruits as well. So this transfer of data is what is called as shuffling. Okay, so this transfer of data is called as shuffling, and obviously this shuffling is required in this use case because we want to aggregate. So that is where we mentioned, right? So if you want to do transformations like a group by, a reduce by, or join, you need to bring the data from one node to the other node. So that process of bringing the data from one node to some other node is called as a shuffling. So shuffling may be necessary in some use cases. And now, is it a very good practice? It's not really good practice because shuffling basically means that you have a lot of overhead, right? Input output overhead. So it has some impact on your performance, but then there are cases like this where shuffling cannot be avoided. So this is one of the best practice that we do, right? So shuffling may be necessary in some cases, but cases where you can avoid shuffling, you have to do, or you have to reduce the number of shuffles so that your performance will be better. But this is basically the concept of shuffling.